welcome back. We are going to solve the 10 questions that were on the practice quiz. This is the first question. Maybe this one is the more subtle question. Let's go to read it. It says a mass of 8 kilograms. Here is the mass. It's suspended of 2 wires. Here is the 2 wires, this one and this one, with attached to a vertical armature in a unifold. So the mass is doing this circular motion. It's a motion with constant speed. It has acceleration to the center because circular motion means acceleration to the center. The acceleration to the center is v squared divided by r. And what it's asking, it gives you the velocity, and what it's asking, the tension in the wire 1. The wire 1 is this one, this tension he's asking you. Oh, okay. So how you will do the problem? You apply Newton's law. How you will apply Newton's law? You will say here is the object. What are the forces that are acting on the object? The forces that are acting on the object is the weight going downwards, the tension of this wire, tension 1, and the tension 2. Okay, these are the 3 forces acting on the object. There is another force acting on the object? No. What happened with the 3 forces? The 3 forces, when you sum, produce acceleration in this direction. So the total force, the sum, should be in this direction. So the sum of these 3 forces should be in this direction, going in this direction, here, in this direction, the sum. So let's go to apply Newton's law. We choose the y direction, this direction. We choose the x direction, this direction. And the acceleration is in the x direction going inwards to the center. Okay, let's go to apply Newton's law. If we choose the y-axis, the vertical axis, the sum of all the forces is the mass by the acceleration. But the acceleration in the y direction is 0 because the object maintains his plane of rotation constant. He's not going up, he's not accelerating up, he's not accelerating downwards. His ay, his change in the y velocity is 0. There is no change in the y velocity. Indeed, the velocity in the y direction is 0 here, and there is no change. He will not go up. He will not make a circle of radius bigger when he go up. He's maintaining this position going around. So what are the forces in the y direction? Well, I see T1 going up, T1. I see the component of T2 in the y direction. T2 cosine of theta is in the y direction. And I see the weight. And the 3 forces summing is 0. Okay, so the picture here is like this. T1 is going up. The component of T2 in the y direction is T2 cosine of theta. And the weight is going downwards. And the weight is the same amount of magnitude that what is going up, T1 and T2 cosine of theta, because the sum is 0. So the weight have to be T1 plus T2 cosine of theta. So we go to the equation and we solve it. So we have the first equation is to apply Newton's law in the y direction. Now we apply Newton's law in the x direction. In the x direction is this x direction. This is the x direction that I have chosen to name as the x direction. This x direction. Okay, this is the x direction, and the body have acceleration in this direction, So the force have to be in this direction. But this direction is changing. As the body is rotating, the direction is going always to the center of the circle, but it's changing. But the value of the acceleration is not changing. The magnitude of the acceleration is v squared divided by r because it's a constant, it's a circular motion with constant acceleration. So, if I write the Newton's equation for the x direction, the force that I will have in the x direction will be T2, this T2, sine of theta. T2 sine of theta is the one that provides the acceleration in the x direction. Indeed, it could be the minus x direction, but it doesn't matter. T2 sine of theta is the mass by the acceleration. T2 sine of theta is the only force in the x direction. M mass by acceleration. So we work now, the problem is already solved. We now just to plug in numbers. So we plug in numbers. If you go to the picture, you will see that the sine of theta is 0.1 divided by 1. Or how? You go to the picture and you will see here the triangle. You will see the triangle. This is theta, this angle is theta. This one, let's go to put it bigger. This one is theta. So the sine of theta is the opposite, 0.8, divided by the hypotenuse, 1. And the cosine of theta is the adjacent, 0.6, divided by the hypotenuse. Okay, so we know sine of theta and cosine of theta. So the problem is done because we have the two equations. This equation and this equation. And these two equations will solve for T1 and T2. Okay, let's go to find T2. So T2, sine of theta is 0.8. We don't have to find theta because we need sine of theta. We don't have to use the calculator. Is mass 8, velocity squared 2.3 squared divided by the radius. Now the radius of rotation is not 1. The radius of rotation is 0.8. See the picture here. And the radius of rotation is this. And this is 0.8. You see clearly? Okay. Now you plug in numbers, and you have T2, you find T2. T2 by sine of theta equal m v squared divided by r. Perfect. So you find T2, whatever it is. Now that you have T2, the problem is asking you for T1. I think it's asking for T1 or T2. Well, to find T1, you go to the first equation. The first equation says T2, that I already know, this amount, T2, cosine of theta, that I already know, is 0.6 divided by 1, cosine of theta, okay, 0.6 divided by 1. So T2, that I already know for this equation, cosine of theta plus T1, that I don't know, is the unknown, minus mg equals 0. This allows you to find T1. I think it's asking for T1 or T2. Well, doesn't matter. You can calculate T1 and T2. It's up to you to work now a little bit the problem. Let's go to the next problem. The next problem say like this. You have this figure. There have two masses, and they say that this mass is a certain unknown amount of mass that you need to calculate in order to fill with the following situation. The acceleration of this, there is friction here there is friction, and there is a static friction. It's not moving, there is no displacement between the two surfaces. It's a static friction. And at the moment that the problem starts, the acceleration of these two bodies are zero. So there is no change in velocity yet. So what it says, for this arrangement of two masses, this mass is known. What is the mass m that when the angle is 20 degrees produce this situation where the little m will not accelerate? Okay, so we do Newton's law. We say, what is the sum of all the forces acting on this body? Friction doesn't exist, I think. It's connected, it's frictionless. Okay, what is the sum of all the forces acting on the M? Acting on the M, oh, there is frictionless pulley. The pulley is frictionless. Here there is friction. Okay, the surface is connected. Let me read. The surface is connected to string. What is the minimum mass that will stick? Okay, the pulley is friction here, is frictionless here. Here there is no friction. Okay, so now on the object of little m, there are three forces acting. The three forces are the tension pulling the body m in this direction. So I'm imagining that the motion, if it takes place, there will be acceleration in this direction, but the acceleration is zero. There is no change in velocity. The static force that is going downwards is holding the tension, the friction plus the component of the weight mg sine of theta, that is the component of the weight in this direction, is holding the tension. So it's an equilibrium situation. So I have t going up, mg sine of theta going downwards. Mg sine of theta minus mg sine of theta is going in the opposite direction as the t positive, the mg sine of theta negative. And now there is the friction force, that the friction force is the mu sub s by the normal. This is the value of the friction force. The friction force is proportional to the normal. More normal force, more friction force. So this is the equation for the sum of all the forces in the y prime direction. So this is in the x prime direction. So this is the x prime direction. If I do Newton's law for the same object in the y prime direction, the equation that I will find is I have force in this direction that is the component of the mg is going downwards. There is a component of the mg in the y prime direction that is mg cosine of theta. And there is a normal force going up. So the mg and cosine of theta and the normal are in equilibrium because the object is not accelerating in the y prime direction. It's not changing his velocity going up or going downwards. So the sum of all the forces are zero. So mg, because the acceleration is zero, so mg cosine of theta is equal n. So the normal, I know already the normal is mg cosine of theta. So I will use this normal here in the first equation. So what happened in the other body, in the mass 2 kilogram? The mass 2 kilogram have tensions going up, have weight going downwards, but the situation is placed in a way that the acceleration of the body of 2 kilogram is zero. So the tension must be equal to mg to produce zero acceleration. So Newton's law equation will say the sum of all the forces in this direction, in the whatever you want to call it, in the y direction, not y prime, in the y direction is zero. So the sum of all the forces in the y direction is tension going up, weight going down. And this is mass by acceleration. But mass is not zero, it's the acceleration that is zero. That is why it appears as zero here. So t minus mg is zero, so t minus 2g, m is 2, is zero, so T is 2G, so the tension is 20 newtons. Okay, but they are not asking about the tension, they are asking about the mass M that will appear here. Okay, so I will go to my first equation on the x prime direction, and I will place the value of the t. The first equation on the x prime direction, this is the sum of all the forces in the x prime direction, is mass by acceleration in the x prime direction. But this is zero not because m is zero. M is what we want to find. It's because ax prime is zero. So let's go to find the m. So the t, the tension, t, minus mg sine of theta, minus mg sine of theta, minus mu sub s by the normal, minus mu sub s by the normal is mg cosine of theta, this is equal 0. The tension, 20. The mass, unknown. The g, 10. Sine of 20. The mu, static, 0.64, have to be the coefficient of a static friction. The m, I don't know, the g, and the cosine of 20, so this produces an equation. You can work with this equation, and the only unknown is the mass m, so you can find the mass m, how much it is. Okay, maybe I made a mistake. If I made a mistake, let me know. Let's go to the third problem. A plastic ball, this problem is the same like the problem on the test, so you do it. This is very easy, it's a very basic problem. It has force in this direction, the weight, 3.6 newtons, and force in the upward direction, 4.3 newtons. Do we have force? Yes, the force is not zero. What we have is 3.6 minus 4.3 is 0.6 newtons going up. This is what we have. This is the sum of these two forces, 4.3. So we have acceleration. How much acceleration we have? Well, the acceleration is the sum of all the forces, the 0.6, divided by the mass. So you can find this one, you can do it by yourself. Okay, let's go to the next one. This one, it say like this. It say you have three forces. So the sum of the three forces will be something. Let's say that this is the three forces, and the sum will be d, the vector d. So the sum of the three forces are d. And the question say, what force you have to add to d to make equilibrium? Well, I have to add a force F in the opposite direction with the same magnitude. If I add F in the opposite direction with the same magnitude, the total force, F plus D, will be 0. So finding the D, I will find the F. That is what it's called, what it's asking me. He asked me to find the F, the force that you have to add to D to produce zero force or zero acceleration. So this is really a problem about vectors, about how to write vectors. So the vector A, this one, the vector A, you see, if you are comfortable to write it, the angle through the positive x direction. The A is 30, this is 35, so this is 55. The A is 30 cosine of 55, 30 cosine of 55 in the I direction, plus 30 sine of 55 in the J direction. Remember that the general expression for a vector is A equal the magnitude of A, cosine of theta in the I direction, plus the magnitude of A, sine of theta in the J direction, but you have to be clear that this angle theta refers to the angle counterclockwise with the positive x direction. Otherwise, this equation will not work. So you have to take the theta that is counterclockwise with the positive x direction. So you take 55. So the A will be 30 cosine of 55 in the I direction plus 30 sine of 55 in the j direction. What will be the V? The V, if I write it in this standard form, will be the magnitude of the 40 cosine of 205. The angle will be 205, it will be 180 plus 25. B will be 40 cosine of 205 in the I direction plus 40 sine of 205 in the j direction. The training that I have given you is to realize that the V also can be written as the sum of two vectors. And what are the two vectors that made V? V is the sum of this one plus this one. Oh, but this one is V cosine of 25 magnitude V 40 cosine of 25. This one, the one in the x direction, is 40 cosine of 25 in the negative direction. So the V can be written like 40 cosine of 25 in the negative direction. And the y part of the V can be written like going downwards, 40 sine of 25 in the j direction. So this expression for V and this expression for V, I think that at this moment should not be surprised that is the same expression. Because cosine of 205 is negative, and this is appear the negative, and cosine of 205 have the same, is the same, if you use your calculator, you will see that the absolute value of cosine of 205 is the same that cosine of 25. Okay. For the C, this is the expression. I'm not going over the C vector. You see the vector C. The angle is 360 minus 40, so it's 320. So the C can be expressed like this. And I leave you to check that the C can also written in this way that is the same that the C. So I will find A plus B plus C. A plus B plus C, I will sum the component, this component of x with this component of x with this component of the C. A plus B plus C, the three components of A, B, and C, plus the three components of the y direction of A, B, and C. So this one with this one with this one. 30 sine of 55 plus So I have the vector A plus B plus C. But the vector that they are asking me is the opposite vector. So let's say I don't want to make the calculation. You can do it. Let's say that the vector D, all these things, is 5. 5i. And let's say that this is 3j. Who is the vector that is asking me? Is the opposite vectors, because it's the vector that when I sum to this, I will get the 0. You see, 5i minus 5i, 0. 3j minus 3j, 0. So the vector f is the opposite to d. So the question is, what is the x component? I think, let me see. The question is, what is the x component of the force of this f? Well, the x component of the x is the minus 5. But it's not minus 5. You have to work a little bit and use your calculator to find what is the correct answer. Okay, let's go to the next problem. The next problem say, you know, that I did a mistake in one video about this problem because I thought about the body B always and not the body A. So it say two blocks A and B, is being pulled around by 100 newtons. So A and B was pulled by 100 newtons. Both of them are moving together at constant velocity of 2 meters per second. to the right. So it means that if he's moving at 2 meters per second, his constant velocity should have a force on V of 100 newtons going to the right on B. Because the sum of all the forces has to be zero in order to produce a zero acceleration, in order to create a change in velocity that is zero, in order to create constant velocity. So the sum of the forces is zero. This means that the acceleration is zero. This means that the change in velocity is zero over the time. And this means that V final equal V initial. So this is the problem. But the problem is asking about, well, the body B will have two forces acting on him, 100 newtons going in this direction, and 100 newtons going in the opposite direction. Now, the body A is moving, here is the body A, is moving with constant velocity. So if it's moving with constant velocity, the acceleration is zero. If the acceleration is zero, it means that it has either two forces that are opposite one to each other in a way that the sum of all the forces are zero, or it doesn't have any force. And you may think, well, the friction force is here, is accelerating the object A to the right. But if it's accelerating the object A to the right, the acceleration cannot be zero. So even the friction force, the force that the object B is doing on A, is switched off. It doesn't exist. So the correct answer is that the object A is moving with constant velocity because, according to the first law of Newton, something moves with constant velocity because nothing is acting on it. So this is the correct answer. This one. There is no horizontal force on A. Okay, let's go to the next one. The next one say, 87 joules of work are needed to stretch a spring from x1 to x2, where x1 is 1.4 and 2.9. What is the value of the spring constant? Now, if you read my video about work and the interpretation that the work, the force by the displacement is this stripe. The force is this. By the small displacement is the area of the rectangle. So the force is not constant. So the force varies with position, not with time, with position. When we talk about work, we talk about forces acting on position, acting on the displacement, and the force acting on the displacement, force by displacement, make a change in the kinetic energy. So the work is 87 joules. And what is the work? The work is the area that is behind the curve. And what is this area? So I have to find the area of this triangle and the area of the rectangle. The area of the triangle is 1/2 the height. The height of the triangle is kx2 minus kx1. You see that this is kx2 from here to here. This is kx1 because I'm counting only the work from x1 to x2. So this is kx1, this is kx2, and this part here is kx2 minus kx1. So the area of the triangle is the base is x2 minus x1. So 1/2 x2 minus x1 multiplied by k x2 minus x1, by minus kx1. This is the area of the triangle, and the area of the rectangle is this by this. This is kx1, because the force is kx1, k by x. At the position x1, the force is kx1 by x2 minus x1. So the area of a rectangle is side by side, side multiplied by side. So the total area is the sum of the area of the triangle and the area of the rectangle. So the 87 joules of work is the area that is here, all this area. So it's force by displacement. Force by displacement, the sum of all this stripe of force by displacement is the total area. So it would be 1/2 kx2 minus x1 multiplied by x2 minus x1. This is the area of the triangle. And this one is the area of the rectangle. So you plug in numbers now, 87, 1/2, the k is the unknown, x2 minus x1, I think it was 2.9 minus 1.4, should be 1.5. 2.9 minus 1.4, 1.5, the k, the x1, 1.4. You make it, you solve for k, and it will give you the answer. Let's go to the next problem. Let's go to see the next problem. So the next problem say like this. It say like this. A mass of 15 kilograms blocks on a ramp of inclined plane 20 degrees above the horizontal is connected by a string of, this is the other mass, assuming that the frictional force may be neglected, so there is no friction. What is the magnitude of the acceleration of the 19 kilogram blocks? So how we solve this problem? We solve this problem using Newton's law. So we use Newton's law for the body of 15 kilograms, and we decompose, we see what are the forces acting on the body of 15 kilograms, and we see what are the sum of all the forces acting on the 19 kilograms, and the sum of all the forces equal mass by acceleration. So we start with the 19 kilogram. The 19 kilogram have weight, mg, tension going up. And we suppose that the motion is taking place in this direction. So the acceleration is going in this direction. So ma is going in this direction. So there are more force going downwards than going up, because the sum is mass by acceleration. So the weight have to be bigger in magnitude than the tension. So the equation that we will place is for the 19 kilogram will be mg going downwards. We choose the positive direction as the direction of the acceleration. mg is positive, t is negative, ma is positive. So mg minus t equal ma, m is 19, 19g minus t is ma, 19 by a, and this doesn't help me to find the tension, that is assuming what is the magnitude of the, this doesn't help me yet to find the acceleration because I don't know the t. So I need to know the t. So I'll go to the body 2 and I see the forces that are acting on the x prime direction. This is the x prime direction. You see the x prime direction? This one is the x prime direction. This one is the x prime direction. Parallel to the plane. So we see the x prime direction, we see the forces acting on there. We expect that the motion of the two body is in this direction, so there is acceleration of this body going downwards, and there is acceleration in the direction or parallel to the plane, to the inclined plane, in this direction. So there is acceleration in this direction. If there is acceleration in this direction, means that there are more force in this direction than in the opposite direction. So more force in this direction means that the tension is bigger than the component of the weights in the direction of the x prime direction. So the tension is bigger, have to be bigger the tension to produce acceleration in this direction, So let's go to write the equation. The equation for the second mass is that we have tension going up. We choose always the acceleration, the direction positive in the direction of the acceleration. So the tension is positive. The weight, the component of the weight is mg sine of theta. This is the component, this is this force. This small force is mg sine of theta. The component is negative, the component of the weight is in the opposite direction as the tension, and this is equal ma. So the tension is 150 sine of theta plus 15a. How I will find the acceleration? Well, I know the tension, but this tension is the same tension that here. I will replace this amount on here, and I will solve for a. So if you do it slowly, if you can do it, and you know that you can do it. So the 190 minus t equal 19a, 190 minus t minus all this equal 19a. Solving, I will take it 190 minus this, and the 15a will go like this, so I made a mistake here. It will be 90 minus 15a. 90 minus 15a, so the acceleration will be here. You found it. If I made a mistake, you let me know. 190 minus 150 sine of 20, yes. Yes, I don't think that I made no. Minus 15a will go plus 15a. Sorry, this is a plus. So you make the calculation and you solve it. Let's go to the one. These are two forces. Two forces of magnitude 2.3 newtons. One is going 2.3 newtons in this direction, and the other one is going 2.3 newtons also in the same direction. So there are 2.3 newtons and 2.3 newtons. And it says the angle here is 40 degrees. So the symmetry would say that this is 20 and this is 20. So now it says, what is the third force that you have to add here to produce zero acceleration? If I leave it like this, the sum of the two forces, the 2.3 going in this direction, the 2.3 going in this direction, the sum will be this force. You see, you know how to sum. You know how to sum this force with the other force. So the force will produce acceleration, because the total force will be this one, the sum, this plus this. Or plus this is the same one. This one is the same one that this one. So the force will produce acceleration in this direction. And I don't want to produce acceleration in this direction. What should I do? I should add a force in the negative direction that will have the same magnitude of this force. So what is the magnitude of this force? Well, I have 2.3 cosine of 20 in the x prime direction, in the x direction, going negative. And I have, due to this force, I have also 2.3 cosine of 20 in the negative direction. In total, I have minus 2 times 2.3 cosine of theta, or minus 4.6 cosine of 20. So this is the amount of force going in the x direction negative. So I should add the force going in the positive x direction to make a sum equal 0. So if I sum 4.6 cosine of 20, this force, the amount of force, will be 4.6 cosine of 20. You need to know going to the right, and you need to know which one it is. Cosine of 20 should be like 0.7, 0.8. So it will be like 4, maybe it's 4.3, I don't know. You make the calculation. It's going to the right, and you may wonder, and what happened with the y direction? In the y direction, there is a component in the y direction. You see, this is the component of the 2.3 newtons in the y direction, and this is the component of the 2.3 newtons due to this force in the y direction. And the sum is 0, because I have so many force going up, going down. The symmetry will do like this. Okay, let's go to the next question. So the next question is something tricky because I have to read it carefully. It says that an object is moving to the right in a straight line. Okay, the object is moving to the right means that it's displaced to the right. If it's displaced to the right because the velocity is the change in position respect to the time, and the change in position is to the right, is displaced to the right, the velocity is also to the right, of course. So the velocity is to the right, the force is to the right. So when the force is acting, the force changes the velocity. So after some times, because it says that the force is acting to the right always, but the magnitude of the force is decreasing. So after some times, the magnitude of the force is smaller, but the velocity is bigger because the force is acting on the object and is making a change in the velocity. So the force diminishes because the problem says that it's decreasing. After some time, the force decreases, but the velocity increases because there is a change in velocity. At the beginning, I thought that maybe the problem that they were asking was like this, was like a force that is decreasing, and later on is negative. But this is not the problem. The problem that they ask is a force that is decreasing and slowly decreasing. So it will be never will be negative, the force. So the force produces acceleration. Acceleration produces change in velocity. So the body is always increasing its velocity. Meanwhile, the force is acting. So what is the correct answer here? So you see, you choose which one is the correct answer. Oh, next one. The next one say you have a work of 4 by 10 to the 5 to raise to the 5 power of joules. You have this amount of work that is done on a car of mass 1,167 kilograms. This is the amount of work, and this is the initial velocity. So if you do work, the force by the displacement, what it does? The force by the displacement make a change in the kinetic energy. When you think of work, you think on displacement. When you think of Newton, you change on time. The force acting on the time makes a change in the momentum, makes a change in the magnitude of the velocity. mvf minus mvy make a change in the magnitude of the momentum. Written strictly speaking, this is the equation that you use for Newton's law. The force produces acceleration. If you rewrite F equal ma, what will say, this equation will say that the force acting on the time produces a change in the momentum. So it's mvf minus mvy. So here the motion is in one dimension. We don't have to use the vector. It says that the amount of work is 4.2. The amount of work that was done is this amount, 4 by 10 raised to the 5 joules. But the work is the change in the kinetic energy. We know the initial velocity. And they are asking, after he made this amount of work, what is the final velocity? Okay, you have all the data, you have the mass, you have the initial velocity and the mass, so you can find Vf squared. Vf square root of whatever. So you do it and you solve it. So my wife said that why I'm doing the homework for you. Because I want you to do it right. I want you to pay attention to what I say and do it correctly. So please, do not deliver a homework of bad quality. Make something with quality. Explain things correctly. Good luck. I'll see you soon.